Welcome to Web Handling. My name is Dave Roisum. In this fluid control video clip, we show how to check precision pressure regulators. Most pressure regulators are non-demanding. These would include things like overall system pressure, slitter raise pressure, clamps, pushers, and the like. In these cases and other cases, a small amount of pressure variation might not cause a degradation of function. The same is true for modest amounts of mechanical friction. However, there are exceptionally demanding process controls that will test the quality of the best pressure regulators. At the upstream end, we may have an unwind break. Here, variation in regulator performance directly causes process tension variations. No less important, and perhaps even found on the same machine, is a winder nip, such as a lay-on roller. Variations in actual nip load, even with the same pressure setting, cause variations in winding tightness, increasing the risk of tight or loose defects. What follows in the video clip is a generic discussion of pressure regulation that would apply equally to hydraulic or pneumatic controls. Of course, this would also apply to any input for the regulator, including manual, E to P, I to P, or digital. Of course, this would apply no matter whether the component is called a regulator, pressure relief valve, proportional valve, or whatever. As with any instrument, we would be interested in measures for accuracy, repeatability, linearity, hysteresis, and so on. While values might have been given for these quantities by the manufacturer, a valve in the real world may be better or may be worse. We cannot assume that a valve will perform properly whether old or new. Measuring valve response is pretty simple in concept. You merely need to ramp up and then ramp down the input while simultaneously measuring the output pressure with an instrument quality gauge. Depending on the details, this might be set up and performed in as little as 5 minutes. However, complicated valves embedded deep in a PLC program can be more challenging, perhaps even dauntingly so. Ultimately, we want any and all sources of valve uncertainty to be smaller than the mechanical friction that we might infer from the methods similar to what we discussed in Web20132d. Shown here is the ideal performance curve for a precision regulator used on a winder lay-on roller. The service engineer is instructed to test this in the field, on installation, and if there are any questions as to performance. You could do this as a series of plotted data points going up and then going down. Alternatively, you might choose to graph it automatically with a PC-based data acquisition program or data logger. You might find, as I have on several occasions, extremely poor valve response. It can be as bad as an output that goes in 3 or 4 steps, while the input is varied smoothly. A badly sticking valve can easily do things like this. So what happens if your valve performs poorly? The first place to start would be the OEM service instructions. However, if you have had more than a couple of failures, you might dig a bit deeper to see if you have the right valve, or perhaps even the right valve supplier. Of course, not all failures are on the supplier's fault. Common sources of trouble relate to fluid cleanliness. Even the smallest particles can cause valves to not move smoothly. Flush lines, clean everything up and retest. Finally, some valves have the ability to dither, meaning they shake the valve to reduce friction. Adjusting the frequency and magnitude of dither might help the valve break loose from modest sources of stiction. Of course, all of these checks and much more should be detailed in a service manual supplied by the OEM. As an exemplar of attention to detail, I offer just one page of more than 100 pages of instruction on a winder hydraulic system. Here, the builder actually redrew and rewrote the instruction for every single component that was more complicated than a pipe fitting, and even a few of those were also similarly detailed. Nothing was left to chance in design, installation, and maintenance. Thank you so very much for watching this module in my Plant Practical series. Please stay tuned for more fluid control design and maintenance tips.